Good afternoon, good morning, good evening, wherever you may be, whenever you may be listening to this. Welcome to the 18th of July Tech Drop-In. This is the APAC session. Today, we're talking all things MegaIX, which is our internet exchange offering, and a sneak preview on a somewhat related but unrelated topic, which is the Megaport Cloud Router IPsec preview feature, which is coming soon. Already teased the end of today's session, but happy to get some questions on that. If you've joined us today live, either via Zoom or you're joining in via the LinkedIn streaming, please feel free to drop your questions in there, and one of the team will hopefully flag it up. They can answer it live, or else we'll take it on for the next session that we do. So a quick little bit of housekeeping for today. A little bit about me. My name is Jason Bordajenko, easily abbreviated JB, and I head up the solution architecture on the pre-sales side for Asia Pacific here at Megaport. I'm based in the Brisbane office, which is our headquarters. And if you do want to reach out and contact after the stream or any other contact method, best way to find me is jb@megaport.com, or do a hunt for that J Bordajenko at LinkedIn. And that's also a good place to have a conversation, given that we stream these sessions out live there as well. All right, so let's break into today's content and try and wrap it up and button it up nicely in our allocated time today. So I've started today with this overview slide, which I had a few questions about how we build out specific use cases. And this is a bit of an overview, not so much of the use cases themselves, but zooming out from specific products, how customers are actually using Megaport services. So one of the most, or two of the most common scenarios that we see are data center interconnect, otherwise known as DCI, and that's where customers are connecting from one of our enabled data centers globally, which number near 1,000 now, across over 100 different data center operators. So the beauty of that is obviously having an agnostic capability. That is, I'm in vendor A for data center operator and then vendor B for another data center operator. It might be across the street in a given metro. It might be given either sides of that city or either state, and even country to country. So all of those services at the DCI speed, and certainly with a few interesting commercial imperatives thrown in there in terms of how we can offer some great bandwidth options on those. And the access product in use there is generally our port product, which is 110 or 100 gigabits per second. When we move to the next model, that is not needing a customer port in both sides, but connecting from a physical location where we are into a cloud service provider, CSP in that case. And that again can be same city, across different cities, different states, or between nations and countries, obviously, in our footprint. So we build out also hybrid cloud models where customers just want to reflect, say, one cloud provider to another and join that, but not using the internet. Then we move into the products that actually do consume or do use internet. And they're on the right-hand side being a virtual edge product, which is used for routing in advance of the cloud-to-cloud product. That's being the MCR, so we call it MVE, or Megaport Virtual Edge. And that allows you to set up the routing components, firewall or security component, or an SD-WAN edge device. And it moves from a platform as a service type model with MCR to more infrastructure as a service, but within that limited remit of different types of functions. And then we actually get to today's functionality, which is talking about internet exchanges. And this is not a deep dive into everything that internet exchanges are or do, but they are a subset of routes that are available on general transit routes, or a default route that you'd get through one of the internet services, as we also provide. Internet exchanges are, again, a very agnostic and neutral way of connecting different networks that have internet peering, and I'll distinguish that today as how peering is different from internet transit. Firstly, we'll look at the markets that we're running our own MegaIX services globally, and there's about 27 of them, so probably a bit too many to go through one by one, but all of the topics that I'll cover today will be a bit generic in terms that they will apply to any of the MegaIX locations. And the new news for those in the Asia Pacific region is we have actually started a new IX just recently in Osaka as well. I do also need to flag that Adelaide, I missed that off the map today, unfortunately, but Adelaide is needing its own blue dot and is growing quite healthily as well. So we have Australia through Singapore and Japan and New Zealand in that map for APAC. All right, so I want to dive in to look at some of the Internet Exchange user profiles, and these are customers that you would expect to see either if you fit into one of those profiles or you're looking at peering with one of those profiles, and we'll take a little bit of a walk through the different motivators and things that they're going to expect from a healthy Internet Exchange and what is the definition that they'd use for that. So the first one that we see and most commonly is an internet service provider themselves, or otherwise known as a network service provider, depending on what market segment they're looking after, or in fact telcos. So it could be a large tier grade type telco network that is doing peering. Then we move along to the content delivery networks. And the definition between this and the last one is generally that you'll hear the eyeball networks is what's referred to where the users are. So they'll generally sit within the ISPs, the NSPs, the telcos, and then the content networks that are providing that content. Now, common ones that you'll see are Akamai, Cloudflare, for example. You might name Netflix as one of those content providers. Any of those providers that have maybe a limited amount of actual IP routes, but a large amount of content that sits behind that as well. Then we move into cloud providers, and cloud providers may also be providing some CDN type functionality themselves, or they may be providing, and I mentioned before the difference between infrastructure as a service and platform as a service, where the cloud providers are offering, say, a storage object service in the likes of S3 with AWS, for example. They will actually make all of those objects available over public IP addresses. And those public IP addresses will then be published to internet exchanges where those cloud providers are present. In the likes of Azure here, for example, you'd expect to see their blob storage product, but separate, though also joined to Azure would be, for example, the Microsoft 365 suite of products. So any of the Microsoft 365 addresses, if you're using, say, OneDrive, it's not actually utilizing Azure as itself as a cloud storage mechanism, but it is some of the same underpinning network infrastructure and obviously those peerings to the likes of Microsoft that make that available. Then we move along to the large enterprises, and where we start to see those typically is in media and finance that actually have a large amount of users that are leveraging internet exchanges. They're still buying internet services, so this is providing a more expedited access. And the example that we give is a customer with a 10 or 100 gigabit per second Megaport can actually fill the entirety of that port if they so wish with traffic that exchanges with peers. And that is important, obviously, when we come to that next one. I mentioned it briefly in CDNs, the content platforms. So if we start looking at Netflix, Meta, Google, for example, when we're talking about the content that they wish to provide, it will either be consumed by those on eyeball networks or enterprise networks, depending on, obviously, time of day, the utilization that they have, whether it's browser-based, whether it's application-based. But effectively, any of those users are able to consume any of those different types of content. Another more specialized area is gaming companies, and they tend to be more looking at obviously distribution of large file updates. So again, might come from a CDN. Not all of these are easy to quantify, but you'll know exactly the IP source ranges. So in this next part of this, and I'll just mention the final one, which is universities and research networks, an area that I've got a personal interest in. They're working with high bandwidth and high utilization of those links. So the drivers behind that, we mentioned the ISPs or the eyeball networks. It's actually looking at reducing their transit costs. So if they're not having to pay someone else to access that traffic, and of course they can reduce the latency or increase the performance of those services that are delivered from all the other categories on the IX. So there's a real benefit for those providers, and they generally peer with multiple IXs in different markets. CDNs also see the performance improvements by getting their caches closer to where users are, and then of course distributed widely across networks, because not every network will be able to install a cache for those CDNs in their data centers. With cloud providers, this is a key one that we're starting to see the customer workloads. They actually start to perform better with lower latency. That's pretty much a given network construct, and similar again, but on the other side of the fence, the consumers of that are the large enterprises. So again, they're getting better routes, they're more direct, they're not passing through too many hops, which is also great from a security perspective as well. Content platforms, gaming companies, they are effectively the same in this, looking at getting that closer to the user. Lower ping times and jitter is a real key for the gaming companies. And then universities and research networks might actually do remote peering, and we'll talk about that a little bit later. And just some of the drivers, we've described a lot of them there, that the CDNs particularly care about the scale. So aggregating those routes, getting them as close to the users as possible. Um, the main area that we see the place that Megaport sit here is educating more on the enterprise side. The ISPs, the NSPs, the eyeball networks generally know exactly what they want. They've already peered. When we start talking to enterprise, the questions are around things like, what is my minimum bar to enter this? And that's why we're doing sessions like today. So I'm just going to touch on a brief video from Alexis Bertolf, who's our global technical evangelist, and it's a great demonstration of what we see come up in the education context, which is the question over bilateral peering or multilateral peering. And I think Alexis does a great demonstration, so I'm just going to play the video, and we'll come back to explain some more of those concepts briefly.
You're connecting to an internet exchange but getting mediocre performance, you might be doing your peering wrong. Most network engineers don't know the difference between bilateral and multilateral peering, but it's costing you performance and potentially money. So if you're connecting to an internet exchange, here's everything you need to know. When you connect to an internet exchange, the first thing you do is connect to their route server. Now, behind the scenes, that route server is facilitating what we call multilateral peering. You're establishing a BGP session with that route server, and in return, you get all of the routes from every network that's also peering with that route server. And this is where most people call it a day. The thing is, those route servers are running BGP with specific filtering rules. Things like RPKI validation, max prefix limits, and AS path filters. And that's great for security, but it means you have less control over your traffic engineering. So adding in bilateral peering can be super helpful here. For bilateral peering, you're manually setting up direct BGP sessions with specific networks you care about that you want to exchange traffic with. This means more configuration and more sessions to manage, but you get way more control over your traffic. Think about it. If you've got a customer that's accessing your services and you're getting their traffic through a route server path that's suboptimal, you're stuck with it. But with a bilateral peering session, you can perform traffic engineering, manipulate path attributes, or even do prepending to optimize that exact route path. So to have a better experience, the best approach is to use both. Get up and running on the route server, and then check your traffic flows and gradually set up bilateral sessions with your most important peers that you exchange a lot of traffic with. Just remember, route servers are great for quick setup and smaller peers, but for the traffic that matters most to your business, make sure you're setting up bilateral peering too. If you need help with your peering strategy or have questions about internet exchanges, just leave a comment below. As always, I hope this was helpful, and I'll see you next time.
It's a great video
You're
covering
connecting
some
to
of
an
the
internet
topics there
exchange
that
but getting
oh,
mediocre performance.
Alexis again, there we go. Come back to our slides. Now, what makes an IX great? What are the key factors? We talked about in the last set of slides, the general inhabitants that we start to see that come towards an IX, and a healthy IX should have a good mix of those peers. But an IX that is actually very healthy has more than just a good mix. It's got obviously high count of participants, and obviously they should be across all of those different types. And the key indicators for that are looking at a local or a same metro IX. So I mentioned Osaka and Adelaide starting up. That's keeping those routes within those metropolitan areas and making those available to the peers within those markets. Now, in the likes of Adelaide, for example, we have seen customers prior to us having a MegaIX location there would actually reach out and do remote peering, and they'd peer in Melbourne, for example. So a smaller network path, a larger amount of peers, but obviously it doesn't fix the latency issue. So by introducing a local IX, we now have a cost neutral. So other than the cost of the port itself, the local IX peering is free of charge. And as I mentioned before, whether that's a 1, 10, 100 gigabit per second port, it's possible for our customers on that free peering to fill that entire port with that traffic, and it's exchanged free of charge. So there's another term that you'll actually hear. Settlement free peering is a common term as well. And obviously that gives a better return on investment on the port. Some customers choose to share their ports, and they can do so with VLANs, and those tag those out, and they can split, let's say, a 100 gigabit per second port into maybe some cloud connections, more on the public prefix side, and then the IX connection as well. So they're allowed to coexist. Obviously, as well as how many and the diversity of those participants, the overall data that's actually exchanged, the volumes that come across that. More data exchanged is better value, of course. It's less that will be actually used on your transit links. We also see, obviously, if people are peering, they're asking about reliability. What's the redundancy? What's the built-in infrastructure behind this? And although most customers are probably quite familiar with what we call VXCs or virtual cross connects, they know they're fault tolerant, they're route redundant. If a backhoe likes a piece of fiber in a particular metro area, the network will automatically route around that. And it is the same with IX. If we have an outage event at any of a particular site in a metro, it's generally not a single isolation event for that metro. We do have the large CDN networks joining us in multiple locations within a given metro, and they actually join to multiple route servers if they're using the multilateral peering example. So we know that downtime will kill trust, and it obviously can affect traffic. It's not the end of the world, though, with IX. Either you have another IX peering, maybe that's within the metro or at a remote site, or you're then able to just, for that duration of an outage, utilize the transit link, but will generally come back to that shortest path link to the easiest recognized next hop peer. So the fault tolerance is actually inherent in the product. And of course, I mentioned a couple of times the route servers themselves. So we run two of the route servers within each of the metro areas, or the MegaIX, the specific IXs that we run in each metro. They're very visible. They're actually registered on what we call a looking glass, and I'll give an example of that in the later slides. This just facilitates easier peering setup, understanding which routes are being propagated to the IX for that multilateral exchange, and the inverse is true. Where we see peers but no routes, that doesn't mean they're not actually participating on the IX. It means it'll have a bilateral request or requirement that would come with it. And of course, all of that comes together to build a strong local ecosystem. And we see that more than just the peer counts. We see that more than just the traffic. But with MegaIX, it tends to be people who've actually worked with each other and that community that it builds out as well, and the community trust that it engenders that attracts a larger market. It's a bit of a snowball effect, more peers, more content, and more investment across the network. This is the screen that you'll see when you get into the portal and actually start configuring IX. And we've moved along to the second last piece. This is step number 4. First one is selecting the type, the port, the connection details. So all of those would be provided, things like VLAN IDs and the bandwidth that you want to allocate. But to this point, we then get to the real piece that is asking for technical information and some quick pointers there. You can see the red asterisk marks. They indicate the required information. So I've actually featured in the text on the right the required and the optional information and what happens, what are the defaults you would need to put in there. So when configuring the IX, you're obviously using your own AS number, and you will require an AS number. You will need a minimum of a /24 of network IP space that is publicly routable and belongs to that AS number as well. That's 256 addresses. It's not particularly a large amount on the internet, and generally the most granular block. And the reason for that is that these are going into global routing tables. And if you think about maybe some older routers that are sitting on the internet, we're starting to see route counts of about, in IPv4 sense, about 1 million of those routes. So any more granular or any smaller subnet sizes, we're going to start to see issues. But by using those larger subnet sizes or aggregating those routes, it is possible to actually have that impact on the global routing table. And I think likely some of the questions that come up when I say the word impact, I'll touch on that at the end when we come to AS set. And we've done some more deep dive technical videos on RPKI or route validation, and Alexis mentioned that in the video as well. But these are the settings that you require just to set up the session with IX before you even get to BGP. So the reason that we're looking for ASN is fairly self-evident. The next one is the MAC address, and this will be a filter that we place on that specific request to say that those layer 3 requests will come from this device. So you do need to specify whether it's a physical or a virtual host, the MAC address that we will be starting to see those requests coming from. The BGP password is optional in this case. There is an option there for graph visibility. Now, some customers have asked about this. Once you actually are on the IX, you can actually choose to show the traffic information that we're collecting, the utilization, the peer exchanges that are happening. You can make that public or you can make that private. So you can allow, if you're using private, only your own internal staff to see your own data, or public where you'll actually start to see the flow information between those peers. It is possible through the tools menu to see that once you have an IX connection for anyone that's marked public, and then obviously you'll see your own private ones as well if you've chosen that option. And the last field, although it is showing as optional in this case, we do have a default. So that's where I wanted to touch on. The AS set is a macro, or it's a field that defines the AS numbers that are actually permitted to originate the routes from your particular connection in this case. If you don't put an AS set in there, we will just filter based on that AS number that's applied at the start. It's interesting to note you can't advertise routes IP addresses that are outside of your own AS, and that's for security reasons. We'll filter on that. Now, the last one is not in this screen so much, but it's a common gotcha that we do see because we are using the route servers and they are in the path of your BGP sessions when you're using multilateral peering. There is a common command, and this is a Cisco command. The commands will vary for different providers, and that is no BGP enforce first AS. And what that means is when you start to see those paths that are returned, if it's coming from our route servers, it will show you the path of the actual peer that those routes are coming from. But the one prior to that will be the AS of the route server. Now, what will be interesting is those IP addresses will actually not originate from the route server, but from the peer that is downstream of that. So by using no BGP enforce first AS, that actually turns off the filtering that's on your own equipment to say it must come from that first AS number. It will actually be downstream of that. So it's just a little gotcha, a quick tip for those that are setting up. Now, I'll talk about the publicly available information first. And the most common site for getting that info is PeeringDB. If you've come to today's session, you probably are aware of PeeringDB, but it's a great source to validate any of the information that I'm talking about today, or even start to query where that might be relevant to you. So if I search here for MegaIX, that's the term that I've used, you'll actually see the IXs that we have globally and now up to 30 in that count. I mentioned the new ones that are coming on board. The networks are the AS numbers that we're using for the route servers, and you'll see in some cases those AS numbers actually will cover multiple route servers or multiple MegaIX locations. And we tend to aggregate those where there's a smaller number of peers because we don't need to allocate as many IP addresses in that specific AS. So bear in mind you might share an AS number if you're using one of the smaller AXs, but that's only going to impact the route server announcements itself. I've delved into the record there for MegaIX Sydney, so same as if you clicked on the left on the Sydney one, which is one of our largest IXs globally, and you can see there over 228 peers, 276 connections, 6 terabytes of what is being described as that capacity. It might actually be larger in this case, where customers haven't necessarily updated their peering speed on their records in PeeringDB. But the really important information I wanted to point out is this is supported by Megaport. A 24/7 NOC is available, and if you are peering on that, you are able to utilize those support services. So we do provide the full NOC services to our IX peers as well, and that is, of course, the global operation. So delving into where the IXs are available and what you'll see when you connect to those. So this, I've looked and delved into the Sydney MegaIX here, and you'll see that we're using a /23, so obviously a larger subnet, and that is the Megaport specified IP address range. So the route servers will fall into that range. It'll generally be .1 and .2. And then when you as a peer, as a customer, complete that form on the portal, you'll actually be given an IP address for your side of the connection. Standing BGP up towards those route servers, whether you're using IPv4 or IPv6 is obviously encouraged, but not necessary. And we'll see the impact of that in a later slide on the looking glass. What I do find interesting with PeeringDB is it does list the facilities with which that IX is available in. And this comes back again to the strength of MegaIX being across all of the facilities equally. And it's a stretch switch. So if you think about it, if you go into a data center, you see a device, that device is actually spanned across all of those locations that fall into what we term that metro. So the definition of metro here, we actually show all of those data centers where MegaIX is available free of charge, and it will join the same, in this case, that /23, that same layer 2 domain. And that's the reason that we place those filters in place. So the strict API validation and the MAC address filtering as well. That's just to encourage no broadcast storms, and we know the peers that are participating on there. If you do a search for Megaport enabled locations, you'll land on our enabled locations page. The URL is given there. And in this instance, I just searched on Sydney, and we can see both the red, the enabled locations, and the blue, the enabled and extended locations in blue, which are where you could actually request a Megaport and then connect to the IX from those facilities. And I've clicked that button on the Megaport enabled locations page that says local IX available. So that's where you will actually not be charged for the IX in that facility to join that metro. If you untick that, you might see facilities where a charge applies. So that's the differentiation of whether that DC is in a metro or maybe in a different metro. And in the instance of the Sydney data centers, there's actually nothing stopping those peers from also connecting to, let's say, another MegaIX in a different location, for example, Melbourne. It would just be a chargeable service based on the speed and the distance banding. All right, I mentioned route servers a couple of times and the looking glass. So the looking glass gives a view to the specific route servers. And the one that we use here is called Alice. That's the software that's underpinning it. And if you go to lg.megaport.com, not the popular white goods manufacturer, but the looking glass, you'll actually come across all of those route servers on the left-hand side with a drop-down. So where I've selected Sydney IX, then you will see four different lists that are available to you. And I've just got one of them on the screen here. But that is route server 1, IPv4, route server 1, IPv6, and then the same for route server 2. So I mentioned there's two separate route servers in different facilities in that metro. Optional to connect sessions again for V4, V6, or to both, but certainly encouraged to use all of those modalities. And once you've done so, what we'll see? Well, we'll get the IP address is under neighbor, and that's within that /23 that I showed for Sydney IX. That would be where that peer exists. So if you're setting up bilateral sessions to them, you'd be using that neighbor IP address. You'd need to negotiate with that peer. PeeringDB is the best place to go to find those contact details. But I have sorted this list by the number of routes received. So we can see over 93,000 routes there coming from Hurricane Electric. You might wish to accept those routes. You might wish to filter those routes. It is up to you, and you can place those filters on your own equipment. You can see the uptime of that connection. It doesn't mean how long that customer's been with us. It's how long that BGP session has been enabled for. So any sort of peer maintenance or any other reboots on their side would actually reset that counter. So some will be for years, some will be for minutes. It's really up to that individual peer. They may do so and balance that across the different route servers. So you may see maintenance that is actually on one of the peers, on one of the route servers, but not impacting the other route servers. So that allows you to build diversity on top of that. And as we go down that list, you'll see a decreasing amount of routes received, but it might be more quality routes as you go through those. If you click on routes received again, you'll actually see those peers that are issuing or receiving from the Looking Glass's perspective, 0 routes. They would be the likes of Microsoft, for example, where you do need to establish a bilateral session. They will have a session with the route server. They won't be announcing any routes over it. It's just to get visibility on all of the other peers that are there as well. All right, so that's come to the end of the MegaIX update session, and I did promise as we got towards the tail end of today, a quick glance at a new feature that the team have been working on and very happy to announce. A lot of our customers have been asking us for IPsec support on the Megaport Cloud Router or MCR, and we're glad to say that's now in preview. It's not on all accounts today, but certainly speak to your sales team, speak to your solutions architect, and they will be able to get this up and running for you. So for those customers who are already familiar with configuring MCR, all we're adding is in the AND details tab, you'll see another option there to enable a package of IPsec tunnels. So by default, we're enabling 10 of those tunnels when you select that option. And this is the configuration details screen that you'll see. So forget what you've just learned about MegaIX. This is not for tying to IX. This is for cloud to cloud or site to cloud connections where you're using MCR, but there are some similarities in the information that's requested. So you can see that we're selecting an IP address, again, V4 or V6 for that specific interface, and we've allocated a /30, a very small subnet in this case, and then you're going to be pre-filling that with that being the source IP address from the MCR's perspective, and destination IP address would be your on-premises equipment or your cloud equipment that's terminating that IPsec connection. There is a requirement there for a pre-shared key, and we'll put in some lifetime values on the phase 1 and phase 2 establishment data that they will be automatically populated. It can be configured in active or passive startup mode, and once again, like all of the other services, possible to switch on NAT translation where that's required, and the MTU value, as we've previewed in one of the other updates that we've done, is now configurable, and we needed to have that as a prerequisite to actually build out these IPsec connections over the internet routes as well. So I'm hopeful that a few of you have been waiting on that feature, have been hanging into the end of today's session to get the update. I'll wrap it for today and say thank you for joining us. I'll see if there's any questions and we'll try and address those either to you on LinkedIn comments, on the YouTube comments, or hopefully see you in a future session. That's all from me for today. Thanks very much for joining and hope to see you again soon.